All right, welcome, Scott. Thanks for being
Thank
here
you.
today.
No problem. Thank you, Jeremy. Glad to do
Yeah,
this.
take it away.
Okay. Thanks,
All
everybody.
right.
Hi, everybody. For those who don't know me, I'm Scott Christensen. I'm GrayMatter Cyber Practice Director. So we're going to talk all things security. Look forward to anyone who wants to join in the workshop and talk about what you're going through and some of the challenges you're facing. Happy to always share what we're seeing in the market. And I'm just going to kind of cover a little bit about using kind of cybersecurity to enable other things and kind of how we want to look at cybersecurity from a perspective of what are the myths in the market. So when I start, I always like to share this quote. Dan Farmer's a real famous PhD researcher in cybersecurity. And I think it's pretty important because when you look at cybersecurity, a lot of times we think of it from the perspective of, I'm only worried about security. And in OT, it's never more glaring the fact that security is not what we're trying to accomplish. What we're trying to accomplish is the risk mitigation to let me do my day to day, whether it's operate a water facility, if it's produce a product, whatever it might be. At the end of the day, security is just a part of enabling the greater aspect of what I'm trying to do. And what are the threats, right? When we want to start thinking about the threats, what are the things should you be worried about? Every year we put out a survey and we talk, people talk about what are the threat vectors. So when you start the first one, and it's the most common one we see, devices and things that can't protect themselves. To me, this is what sounds like to me. PLCs, VFDs, all our little favorite little 3-letter acronym devices are dumb computing devices that we really rely on. Those are the devices I can't load antivirus on. They don't really protect themselves well. So I have to put other things in place like compensating controls. And then you always see internal and external threats. The accidental, someone clicked a link they shouldn't have from a phishing scam, or the hacker trying to break into my network. We know those threats. Those are pretty well documented. They've been around in security for a long time. But if you look at number 4, I think number 4 is becoming a pretty interesting one because 5, 6 years ago, we really weren't talking about ransomware and OT. It was really something that banking and healthcare was dealing with, specifically hospitals, people who had this private data. Because what was happening is they would lock them out, they would charge for the ransom, but those environments started protecting themselves against ransomware. So they got better about preventing ransomware from getting into the systems. So what happened is the attackers started looking for other targets, and they kind of came up with a few criteria that they really enjoy. The first being people who have lots of data. As we just saw things like a million tags come into play, we know lots of data is what we deal with. Second, people with outdated security paradigms or outdated security systems and tools. That's, think about all the environments we work with. A lot of times we're dealing with very outdated systems, unpatched operating systems, old infrastructure. And then lastly, people who have a willingness to pay to get back the access to the data. And for me, that absolutely screams production because we're so mindset on how do we protect our revenue stream? How do we keep the operational environment going? Those day-to-day operations that we're willing to pay to get quickly back. So quickly what we saw happen is a pivot from the traditional banking and healthcare, and we started seeing OT get hit. And in fact, last year over 100 ransomware were hit within municipalities in North America alone. And I always put up the slide with the history of ICS attacks, and I'm sure you guys have all seen multiple different versions of these and lots of different conversations, all the way going back to Stuxnet and really the first attack, 1980, the Trans-Siberian Pipeline, which is where the NSA decided to insert Trojan malware to turn off the safety regulations on a pipeline that the Soviet Union was trying to build. Really, when you highlight that, it really just shows that over the years, we're getting more and more sophisticated in how we attack networks. And now we're seeing that ICS is becoming a very targeted part of attacks. So people are going after industrial control environments. They're really trying to hit OT because they actually see it as an avenue to attack the greater environment. So what are some of the myths when we start thinking about this? The first big myth we hear over and over again is I have an air gap. And Sean McGurk used to direct the NCCIC, which is the Homeland Security Cybersecurity Task Force. And he has this quote, and basically every assessment they'd ever done, they never found one truly air gap network. And in my career, doing this for 20 plus years, I can say it's been on one hand how many times I can count even something I would consider an air gap network. It's pretty rare outside of a couple very heavily regulated industry like nuclear. For the most part, when you start to think about the way we interoperate, not only is the air gap becoming harder and harder to even maintain and keep, you're losing a lot of the advantages as you modernize your infrastructure. So really trying to put a lot of effort into that. And then when you start thinking about how I defeat an air gap, I can defeat it with something as easy as what we call sneaker net, walking around with a USB stick, dropping it in the parking lot, sending out phishing, having someone opening up their phone on the SCADA terminal, charging it there. There's lots of ways to do it, and you've lost your visibility. So I can live in your network, and I can actually turn the air gap into my advantage because you think you're disconnected. So you've got this false sense of security, and I can a lot of times live inside your network doing damage without you even realizing I'm there. The next big one we start talking is OT really isn't a target. When you look at the sectors, energy, manufacturing, water, those make up the proponent of attacks on environments. And then you really look at the breakdown of what's being attacked. Your traditional kind of SCADA infrastructure is pretty high. You look at the PLCs, a quarter of the time are attacked, and then 58% of the time engineering workstations are attacked. So these are a lot of times a very easy avenue because engineering workstations are often unpatched, unsupported, operating systems. So it's very easy to kind of target these. And if you look at what happened during the pandemic, we saw a massive increase, a 600% increase in attacks because we started working and relying on remote access more and more. So we started seeing an increase of attacks on ICS environments. So I think it's really important to start thinking that, OT, you're becoming more of a target. The next one is, I heard this very recently, that the risks are actually higher in IT than OT. And I find that kind of interesting when you really look at the concept and you think that, these numbers come from the Department of Commerce, and they basically average out what would be the cost of industrial downtime. They basically average it out about $260,000 an hour is what it would cost. In some industries, like the auto industry, it could be up to $50,000 a minute. I recently was involved with a remediation effort with a customer, and they figured their number was $8,000 a minute was what it cost them to be down. So when you look at the impact and you talk about the risks, a lot of times we don't take into account that at the end of the day, the OT side of the house is the profits center of the business. We're the ones who generate what happens. So when you think about the risks, it's so much higher on the OT, in my opinion, than the IT. So when we only kind of focus and put our investment in protecting the IT infrastructure, we're really leaving a pretty big threat avenue available to the attackers. So how do we start protecting it, right? So what are the things we want to look to do? So first, NIST cybersecurity framework. It's a nice, easy, good, clean standard to kind of measure your risk. And it gives you 5 control areas that allow you to kind of measure the different types of techniques, tools, products you should be looking for. So first you look at, can I identify all my assets, all my critical data? Where does my data flow? How do things communicate within my environment? What are my most critical pieces of my infrastructure? So once I start identifying those and I start identifying what the potential threats could be to those, then once I've done that, I can start moving into protection, right? I can start looking to say, how do I protect those? How do I keep my operations good and clean and hygienic day to day? Then I want to start moving to proactively trying to detect threats as they happen, and so that I can quickly find when an incident happens and when someone's impacting my network. And then I move on into kind of my reactionary, what is my response plan? Have I communicated it out? Do I have the tools in place for my team to quickly respond to a threat? And then last, can I recover? Do I have good backups? Do I have good solution in place that allow me to get back into full operations and reduce the impact of downtime? So when you start looking at those, I really want you to think about different solutions and different services and products that you have in each of those 5, because they're really designed to kind of cover overarching what you're looking to protect within your infrastructure. One of the things we really promote is, when we start talking about deception technology, and we want to move into that kind of both detecting threats and protecting against threats, we think this is a pretty powerful tool for doing that. So by sitting kind of in that perimeter between the production environment and the greater world, whether it be the business, the internet, other networks, whatever it be, we kind of want to sit in between. We kind of want to re-harden up that perimeter. And what our goal is really to try to do is we want to try to create fake assets. We want to look like industrial assets. We want to replicate what's actually in your environment. Because what we're trying to do is, if an attacker is in, we're not trying to lure and be juicy to bring attackers who would not be attacking. But the concept is they're already in your network and they're trying to use whatever vulnerabilities they have, and they're trying to look for good targets. So we're trying to give them some fake targets to go after. So as they go to try to look at the fake targets and they try to do their initial reconnaissance scan, what we're going to do is be able to react quickly to them because we've lured them away from my critical operations. And now as they're communicating with my fake assets, I can then create an automatic response. Because they're fake assets, I can say, there's no reason for you to be communicating. I'm going to lock you out of the rest of the network. I can also limit what you're allowed to do. I can learn what you were trying to do to begin with so I can remediate it in the rest of my facility. So if you think about it, if I see someone coming in on a specific port, I know they're trying to communicate with a specific type of PLC, and it's a specific version and an application they're trying to use. I can then go into my network and say, you know what, let me patch that system, or let me make sure that I control what's communicating with those PLCs running that version. So I can actually use this to protect. And even the network detection tools will appear to be, an industrial asset. Will be a historian. Will be a SCADA server. Will be whatever it might be, a VFD. We can replicate that. So we'll actually not only replicate the asset, but the communication of that asset. So if a PLC and an HMI communicate back and forth, we want to replicate that back and forth communication so that when someone is outside the network, we're trying to entice them, we're trying to fool them into thinking, hey, I'm that asset, come communicate with us. And one of the great byproducts of this is that we're actually able to see what comes and goes out of the network and where it comes from. So firstly, I can say, let me look at regional information. So if I get an odd uptick in traffic, and we'll pick on Antarctica, there's no reason Antarctica should be reaching into my OT network and trying to communicate. And all of a sudden I see an uptick in Antarctic traffic. I can immediately block that traffic out of my network and decide what it is. So I can actually create a fence around my environment. We call it geofencing. So the concept is I can really limit what regions are allowed to communicate. Knowing that there's some regions out there that promote, malicious activity, I can take advantage of that. Secondly, we're tracking global networks, and there's two types of global networks that we track. So the first type we track would be your traditional kind of enterprise global networks, your Googles, your Facebooks, your LinkedIns, your YouTubes. You can decide which types of those networks do you want to communicate with your ICS. So if you think about it, I can say, there's no reason social media needs to be touching my production network. Let me just filter that from ever touching my environment. Secondly, the other type of global networks, and this is kind of a key point, is we're actually tracking the malicious networks, the dark web sites, the malware delivery sites, the ransomware sites. So because we sit on both sides of that perimeter, there's a couple things we do is the insertion. So those networks trying to communicate into my network. But one of the things oftentimes will happen is devices on the inside will try to call out to those type of networks. They'll try to get their command information. We can actually block that extraction as well. So really by sitting on both sides, we're able to both prevent insertion of malicious behaviors and prevent extraction of data. So we're allowing you really kind of a comprehensive protection at the perimeter. So when you look at some of the advantages, right? I've talked about the global networks. Those are big ones. I can track data flow. I can track what ports are open, what source and destination information. I've said this before, and I think one of the big things is it's almost like I'm using the negative attacker, the malicious person, as a pen tester for me. So I'm letting him tell me what potential holes they're trying to poke in my network, and then I can fix them because he doesn't even know he's in my sandbox. I can control what comes in and out. I can limit what type of data. If I don't want to allow email, I can block that out. I can throttle communications as well as block it. And one of the best parts about this device is it's designed with an industrial mindset. So the device itself, if there's a power outage, if there's a failure to the device, it's not going to be a point of failure to your network. It's actually going to be designed to fail open and continue to pass communication. So it's got an industrial mindset with it. So when you start moving on to the next, one of the things we often want to talk with customers about is what are they doing for version control and backups, right? We start talking about those 5 key areas. We're starting talking about recover, right? So are you tracking your versions? Do you have a centralized management? Is it agnostic to the assets you have in your environment? Can I keep my PLC programming logic version tracked and changes? So I can always go back to not just the most recent backup, but can I go back to the last more versions back? Can I go back to the best good backup? Can I look at who's been making changes? I can actually track and prevent people from making changes. So that's really what you want to look at when you start talking about version control technology. And then when we start looking about networking, I really encourage everyone to look at zero trust networking, knowing what assets are on your environment, who's communicating with what, and then becoming prescriptive of that. So not just knowing what's coming and going, but only allowing what I want in and out of my network, really extending my perimeter and really taking into account all the data that as it comes in and out of my environment and locking down and encrypting that traffic. It's going to be really critical to kind of protecting your environment. And then, of course, got to do the commercial with GMS. Some of the things we've been working with customers on: network visibility, understanding your assets, your asset inventory, keeping continuous monitoring with that. Infrastructure and connectivity services. We're doing a lot of risk and vulnerability assessments, both your traditional kind of NERC-CIP as well as AWWA, AWIA assessments, as well as working with NIST people to try to become compliant with NIST or one of the other standards out there. We're doing a lot of network design, so we've got a very skilled group of OT network people who understand kind of the challenges of an operational environment. And in tuning your network as well. So if you have troubleshooting issues, you've got that aging infrastructure, you're looking for where are the pieces that you need to protect and upgrade, we're happy to work with you on that as well. And then how do I start, right? What are the things I can do to kind of starting to address these risks? So when we look at it, you want to look at first people, process, and technology. Are my people following best practices? Do they know the threats? Do I have the right policies in place? I oftentimes talk about security versus practicality, that I can be ultra secure and locked down and nothing works, or I can be ultra practical and everything's open, but I'm constantly remediating threats. So finding that balance. And it's not always about buying the newest tool. A lot of times it's about making sure what you've invested in is properly configured. We see this a lot of times with firewalls. I can deploy a firewall, but if I have a bunch of any rules, everything's getting in, so the firewall's really not doing anything for me. So really evaluating what's in place today and making sure you're getting everything you can out of it. And so when we start looking at our assessment philosophy, once again, it comes back to that same, those 5 key categories, right? I've identified the potential critical assets and threats. Do I have protections in place? Am I constantly detecting as incidents are occurring? Do I have a well-communicated response plan? And do I have the capability to recover quickly from an incident? And then as we look at an assessment itself, what are the things we want to look at? We use a three-tiered scoring system, and the reason we use this is that it provides a little additional context. We can take a standard such as NIST, and we can give you a standards-based score. This is kind of a yes or no. Do you have these things in your environment? Do you have access control? Do you have backups? Do you have a documented password policy? All those type of things. But that really doesn't show a lot of context. It just says yes or no. Do you have it or not? So the next we'll go with like a component scoring. This is what we use a technology, and we'll take a span port, we'll look at traffic, and we'll try to understand based on that an objective risk score. It says based on your environment's current configuration, this is what we see your score being. And then lastly, we'll provide an observation-based score where one of our analysts will come on and say, putting things in context when it look at risk. So if I see, for example, an unpatched operating system, it's very different if that unpatched operating system is publicly facing versus siloed and segmented away. So I won't treat them the same way. So I can actually provide context by using that observation-based scoring. And then lastly, not just showing you where all your exposures are, not just saying, hey, here's all your vulnerabilities, go fix them. Actually providing both remediations and recommendations. So for us, remediations are, here's the way you should to address an issue. And then recommendations are, here's how we would actually apply that remediation. So here's a roadmap to addressing those concerns. So actually outlining what it would take to do all this. And with that.
Scott, thank you. Thanks for covering so much ground so quickly for everybody. I really appreciate it.